Welcome to the fifth video in the series on the general care and maintenance of the AMS instrumentation and control filling valves, also known as refuelling control valves or flyte valves. The valve has been designed to allow customers to self-maintain to minimise cost of ownership and increase its time in service. This video shows how to complete a basic refurbishment or service with our standard spares kit, which we recommend is completed at least annually on trains in regular service to ensure correct operation and increase the product's lifespan. If looked after correctly, as a simple mechanical device, it is possible for the valve to outlast the tank it was built for. As it is used as part of a system to prevent overfill, it should only be taken apart and maintained by a competent and trained person. All checks and refurbishments should be carried out in a clean workshop environment with the correct tooling. Using suitable personal protective equipment, follow the inspection process shown in the second video of the series to identify if there are any obvious issues such as damaged float arms, broken floats, damaged float mechanisms and faulty valve heads. If there is damage to the float arm or float mechanism, the product should be returned to AMS for a complete overhaul. These parts are not offered as spares, as they are matched parts to ensure compliance to specifications, and the criticality to the operation of the product requires them to be pressure tested and flow tested following replacement. If you are happy that the float mechanism assembly is working correctly, continue with the product service. Take the valve apart following the procedure in our disassembly and assembly video so that the main parts are separated and on a clean work surface. Although in some cases the spring tension is likely to be sufficient for operation, we include a spring in the annual spares pack and recommend it is replaced annually, as testing of the spring tension to make sure it doesn't reduce before the next service is difficult to achieve. Using a suitable cleaning station and parts cleaning fluid, clean each of the valve parts to ensure they are free from possible tank debris and fluid buildup. Inspect the valve body for signs of pitting, nicks or other damage to the internal and external faces. It is critical that there is no damage to sealing faces. If there is damage to the internals of the valve body, or there are signs of cracking or corrosion, then the valve is beyond repair and should be disposed of safely. As the correct fitting of the valve head seals is one of the main causes of failure from customer or subcontractor refurbishments, we've produced a separate video in this series showing the process to follow when replacing both the distributor seal, part number SV332, and the valve head seal, part number SV20. Both these seals and a replacement circlip are included in the service pack, and we recommend this procedure is followed as part of every service. The locating pin should be identified when you carry out the inspection process at the start of refurbishment. If it has fallen out after taking the valve apart, ensure it is refitted to the correct hole to ensure that it goes back into the valve body with the blanking space on the valve body in the correct location. Remove the split pins from the upper spindle on the base cap and discard them if necessary. There are replacement split pins in the service pack. Clean the seat and head of the pilot valve and visually check for signs of damage, such as pitting or small nicks. Any small damage to the pilot valve can cause intermittent failures when installed. Valves with damage here should be returned for a complete overhaul and retesting. Clean the base cap and ensure the bleed hole is free from any debris or fuel buildup. Even a small amount can affect the valve operation. Inspect the valve seat carrier, part number SV354, and check for signs of splaying to the fork end. This is the most common cause of valve failure and is normally a result of poor product handling or bad storage that has led to pressure being placed on the float mechanism. Even small damage to the fork can result in failure. The carrier on the right shows a slight splaying, which could pass an operational check now, but would almost certainly fail in service before the next service is due. As the tolerance is so low and possible to miss with the naked eye, the gap should be checked with a go, no-go gauge to ensure it is within 3.175 cm and 3.225 cm. We are able to supply gauges for this operation, or your engineering team can make or procure one themselves. If the carrier passes the checks, then the pilot valve and base cap assembly can be put back together, ensuring new split pins are used if necessary. Put the valve back together as per the assembly video. Once assembled, the functional check and a product inspection should be carried out as per the separate videos in this series to make sure it's been put back together in line with the product specification. If the float arm is marginally out of position, yet all the components have been checked for damage and the component dimensions confirmed, then the adjustment screw can be used to align the mechanism so it is parallel to the product flange and within the tolerances of the inspection. Once aligned, the split pin should be refitted to prevent further tweaking of the adjustment screw. The adjustment screw is designed for the reassembly process following service only. Using the adjustment screw to correct the arm position without carrying out a service first is likely to result in a valve being installed that will either fail intermittently or completely fail before the next service. Tweaking the screw before checking the components simply masks damage that may have occurred. Once the valve has been serviced, make sure the handling and storage guidelines are followed to prevent damage before it is installed.
Thanks for watching. More information on our product range and maintenance can be found on our website, or contact us via sales@ams-IAC.com.